for some more easy stuff? Yes!
Yes! Okay. So what we can do is we've talked about figuring out the molar ratios and kind of looking at the molecular versus the empirical formula. Now what we're going to learn in this video is how to actually take masses or molar amounts to figure out the molar ratios and then determine the empirical and molecular formulas.
Okay, so it does kind of relate because we're using molar mass.
Yes, and we are using moles. So it's we're kind of taking what we did last video, and we're taking it maybe just a teeny tiny step farther.
Okay.
Not really all that much. And so what we can do is really we can look at this process as two different methods. Okay, at least what we're going to look at. There's a lot of different ways to look at this, and if you talk to any of your pre-AP friends, they may or may not tell you, because I know that's what y'all do, at home as you talk about chemistry.
I do all the time.
That's what I do. So yeah, let's get into it. If we're looking at it, we've got one method where if your problem gives you moles. So for example, if I give you a compound that has 3 moles of hydrogen and 1.5 moles of oxygen, what would be the empirical formula?
Since you gave me moles, I'm assuming this has something to do with mole ratios.
Right, and so this is really nice because what we can do is we can make our molar ratios, and there's a really particular way to do that in this particular case. And so what we want to do is we want to take the number of moles.
You should probably write this down.
Good idea. Over the smallest number of moles. And so what we want to do is we want to do this little process, that little process, for all of the mole numbers that we get. So we've got 3 moles of hydrogen, and we're going to put that over the smallest number. So which one's smaller, 3 or 1.5?
1.5.
Right, so we'll put that over 1.5, and then we'll go ahead and set up the other one, which is 1.5, over the smallest one still, and then we want to go ahead and divide them out. So if we get the calculator, 3 divided by 1.5 is 2. So we put a 2 right there, and then 1.5 divided by 1.5 should be relatively easy. It's 1.
Man, you're so good at this mental math.
So then what we want to do then is we want to take these.
So does the 2 and the 1 give me my mole ratio then?
Yeah, basically, which would also give us our subscripts. So the 3 moles came from the 3 moles of the hydrogen. So when we write our hydrogen, we had 2. And then the oxygen, when we did the 1.5 and the 1.5, was our 1. So we don't have to write anything there. So that means our empirical formula in this particular case would be
H2O.
H2O.
Simple division. I like it.
Not too bad. I mean, we're still working with the molar ratios. We're just making a couple of little changes. So another way we can look at this is we can see if we're given grams. So we've got a mass.
Okay.
Okay. So for example, we've got the empirical formula for a compound is NO2. The molecular mass of the compound is...
molecular mass.
Okay, so let's back up a little bit. Molecular mass is a fancy way of saying
molar mass. Okay.
Yeah, same mass, more syllables.
And I thought that's what I hate about chemistry and science in general. They can use all these different words, and they're talking about the same thing.
Well, that's true. But, I like it because there's just a wealth of ways to describe what we're all talking about. It just adds so much color and life to the language of science.
Oh, yes.
Science. I was an English major too, on top of the science major. Okay. So the molecular mass, the molar mass of this compound is 92 grams per mole. What is the molecular formula? So we still want to get that molar ratio.
Okay.
And so what we want to do is we want to take the mass of the molecular formula, and that's a whole lot to write, so I'm going to go ahead and just shorten that to molecular formula. We're going to divide that by the mass of the empirical formula. I don't know what M means. All right.
So would molecular mass, the 92, would that be your molecular formula?
Yes.
Okay.
So we can also say here. Well, that's a good point. So mass of, or we could just say, okay, come on, Mr. Thompson, molecular mass. So these two right up here, they would be the same thing.
Okay.
And so then we've got the mass of our empirical formula. Now, they didn't give it to us, but that's okay. We know how to figure it out.
Do we?
Well, it's just the same way as trying to figure out good old regular molar mass.
Is that from the periodic table?
Yeah. So
Okay.
when we look at, let's see, we need nitrogen, which is
14.007.
right? And then we've got 2 oxygens,
All right.
and those are 15.999.
999.
Okay. Yeah.
Whoops, I guess it would help if I would punch this in the calculator correctly. Please make sure when you're putting this in the calculator that you punch the buttons correctly. And that the calculator registers it. Red. There we go. So I got a molar mass, or molecular mass, of the empirical formula was 46.005.
6.005. Okay. This is getting a little bit messy, so I'm gonna clean it up just a little bit. So we've got let's see, we had molecular mass, which was
92?
92. And then we're going to put that over the
Empirical formula's mass,
yes,
right?
empirical formula mass, which you calculated to be 46.005. We can go ahead and just say 46, just for the sake of making it easy. And then we want to go ahead and divide those.
All right. I put the top number in first, correct?
Yep.
Okay. 46. Whoa. Whoa. 2.
2. So this number is going to be similar to the molar ratio. So what we want to do is we want to take this number 2 and multiply the subscripts of the, I'm going to shorten this again, the empirical formula.
So since it was NO2, I just double everything?
Yeah. Yeah, I mean, if it was, if this number was 3, we'd triple it, that sort of thing. And by whatever we got number one. So like you said, it was NO2. If we double both of those, it gives us
N2O4.
N2O4. So the molecular formula would be N2O4.
So really all I have to do is follow the directions.
Yeah.
And the calculations are there for me.
Yeah, basically. Okay, so work on your guided practice. If you have any questions, let us know. Come back and see us in a couple of minutes, and we'll kind of go through these really quick.
Welcome back!
Okay, so let's go ahead and take a look at these guided practice. So the first one that we've got is one of them that we have the moles. All
Okay.
right. So we want to go ahead and do that first method where we're looking at the molar ratios. So, looking at that, which one's the smallest number of moles?
Okay, can we do something? Because
Okay.
can we, whenever we just pull them out, because I like to do it, I think it would help me if I wrote it, and my first one is K, so I'm going to write K, and then I'm going to put 0.5,
Okay.
and then get it set up, and then I have N, so that way I don't have to read back into it, I'm just pulling this stuff out, and then I have O, and this is 1.5. So now I have all of them already listed, and then it's easy to see that the lowest one, okay, but if they're both 0.5, does it matter? I just use 0.5 on the low.
Yeah, you just use 0.5 on the
Okay, so I had to put all of my number of moles on top, and then I put the
Right.
lowest one on bottom. So
Right.
it's just I put 0.5 all the way across
so we
on all
can
of
put
them.
0.5 underneath them all. So, you want to plug them in real quick.
So that'd be
That's
1,
1.
and 1, and then, 3.
Yes. All right, so we've got 3. So that means we've got our ratio. We've got our subscripts that we can use for the K, the N, and the O. So we can go ahead and kind of put all those together.
Be 1K, 1N, and then 3O, so KNO3. Potassium nitrate.
Yeah.
Cool.
Very good. And all right, so now we've got one with the using the masses.
All right, so we have to put the molecular formula over the empirical formula's mass.
Right. So they gave us the molecular mass.
So 56 is what I put on top.
Right.
Okay, and then I have to go to the periodic table and find the mass of 1 C and 2 H's.
Right.
So C is 12.00, whoops, no, 12.011.
Mhm.
And then I've got to add
2
2
hydrogens.
times 0.0. Oops, I'm trying to go crazy with it. All right, so I got 14.028. We just said 14?
Yeah, we can just say 14. That's
Okay.
fine. All right. And so now we want to go ahead and just divide them like we have them written there.
All right, so 56 divided by 14 is 4.
Yeah.
All right, so that means I just do my basic formula, which was CH2, and I just multiply the subscripts times 4.
Yeah.
So that'd be 4 C's. And let's see, 4 times 2 would be 2. I don't have enough fingers.
Carry the 6.
8?
Yes.
Okay. C4H8.
So that would be your molecular formula.
Easy peasy, lemon squeezy.
Not too bad. So work on the practice.
Follow the directions.
That's a biggie.